Dear students, welcome to another lecture in industrial engineering. Yesterday we started the new topic, that is ergonomics. So we have seen introduction about the introduction of ergonomics yesterday, and now continuing further on the same topic, let us start with this subtopic now, that is man-machine relationship. See, in ergonomics, the system, this is the fundamental concept. See, you have studied about machine design or design of machine elements. So when you are designing a machine element, see, machine, no, as such we design separately. It has a separate identity in machine design. Okay, but what we observe is that this machine cannot perform without the operator or without the man. But in ergonomics, a person who is using ergonomics, who is called ergonomist, see, he considers man and machine as a joint system. He will not just design machine without bothering about anything about man. You see, he will take both together and look at the things. When he designs, he will fit the machine to the man. He will fit the man to the machine, like that, to perform combination of activities to obtain desired output from the given input. See, this is what you should see. That in ergonomics, these two are seen as a joint system, whereas in machine design, we see separately the machine and design. But nowadays we are incorporating the ergonomic principles even in machine design. That's why we studied one topic there in elements of machine design, the topic ergonomics. Okay, a system is composed of, when you say a system, it is composed of human beings, machines, and other things. These work together to accomplish some goal, which cannot be produced by these same elements independently. You see, if there is a screwdriver alone, what can it do unless a man takes it in his hand and uses it for tightening the screw or for loosening the screw? You see, as such, the screwdriver cannot do anything. Even power tools, you see, lathe machine is simply there. You see, what can it do without a man going and operate it? You see, CNC machines and fully automatic machines, such machines, may be able to perform for certain duration of time without the intervention of man. But after certain time, definitely they also need human intervention. So man is necessary. So man-machine system or man-machine relationship, this can be defined as this: a combination of one or more human beings and one or more physical components interacting to bring about some desired output from the given input. Okay, this is the definition. Okay, man-machine system consists of any type of physical objects or devices or equipment, facilities, activities performed by man. It consists of all. It may consist of any of these things. It may consist of one physical object or many physical objects, devices or equipment, facilities. Okay, and man performing the activities with the help of these physical objects. So in this definition, what we are saying is it can be one man or more than one man, and he is taking the help of these physical components or physical objects, you can say, and interacting with them He is engaging them, he is using them, he is manipulating them, he is operating them. What for? So that some desired output you can get from the given inputs. Okay, this is the man-machine relationship. Now let us see the classification of man-machine systems. There are broadly three categories. The first one is manual system. You see, manually doing the work. A manual system consists of hand tools. You see, as I said, a screwdriver is a hand tool, or other aids which are coupled by a man who controls the operation. Now, man is controlling the operation. Okay, suppose there is a spade. You want to dig. You want to dig. So unless you take the spade and put your energy and dig the earth, dig the ground, you're not going to do anything. You're not going to, nothing is going to happen. So the operators use their physical energy as the power source. This has no electric motion motors or IC engines or any external energy. Only the human being's energy, the physical energy of the man, that is used for operating those things. Such a system is called a manual system. Then second system is mechanical system. See, mechanical system is, you can say it is semi-automatic. Partly man's intervention is needed, and partly it will work by itself for some time. It consists of well integrated physical parts such as powered machine tools. So here motors are there, engines are there, conveyors are there, or some such kind of things are there. It is generally designed to carry out some functions with little variation. Power is typically provided by a machine. Now it is, in the first case, no, man only is exerting the energy. Here, though, the energy is exerted by, or the energy supplied by the machine. But then what for man is there? Man is mainly used, man is mainly present there for guiding and supervising the things. You can say like that. So that is a mechanical system. Then the third system is an automated system. In automated system, when the system is fully automated, it performs all operational functions without human intervention. But still, this automated system requires man, so that for what for installing the programs, for running the programs, for reprogramming it, for debugging it, to maintain the machines and all those things. For that, man is needed. So though it is a fully automatic machine, even our washing machine in the house, we say fully automatic, but what, it can work by itself completely without man? No. See, man's intervention is needed. Okay, so these are three types of or three categories of man-machine systems. Now let us come to this diagram here. This is a closed loop man-machine system. So here, see, you can see on one side we have machine, the other side there is man. So when man is operating the machines, he will he switches on some buttons, or he gives the power supply, or he will initiate some action. So when when he initiates some action using the machine controls, the machine responds, and when it responds, it gives some information, and that information is displayed through some kind of display boards, or some panels, display panels or something. Okay, thereby now man, what he does, he receives the information. information reception he does, and then what he does is he will see whether any corrective action is necessary. Okay, he will, it is more like feedback. you know this this is, suppose you are going on a motorcycle, okay, and you are going at good speed. Suddenly you see that there is a speed breaker at a distance. Now immediately what you do, see, you reduce the accelerator, and you apply the brakes. Okay, see, these are the controls. And then immediately what happens is the bike slows down. You see, immediately you can see the speedometer, this thing is coming, the needle is coming. Earlier maybe it was going at 80 speed or something, suddenly it has dropped to 50 or 40, something like that, you can see. Or even otherwise, he can sense, the driver can sense, the rider of the bike can sense that it has sufficiently slowed down. Then he has to take some more corrective action, okay, so that he will not face any problem at the speed breaker. Okay, some corrective action. Okay, maybe along with the foot brake, a hand brake also he may apply, or you know the accelerator he may completely you know completely reduce, or something like that. Some corrective action is okay, he can do. So you see, the closed loop, why we are saying, because man is doing the feedback process here. So you see, for some input is given to the machine, and it started with the help of this input, the machine starts operating, and and in the same time it shows some display of information, and that display of information is seen by the operator, through the eye or through the ear. Sometimes by the sound also we'll be able to say, or just by his experience he'll be able to see. Sometimes by temperature and other things he can sense with a touch of the hand or something like that. Okay, and then he will take some corrective action. So like this is the loop. Okay, so see, from display instruments, operator gets information about the operations of machine. If he feels that a correction is necessary, he will operate the levers or controls manually. After doing corrections, he can observe the change in the performance of the machine, which will be indicated on the display panels. Okay. Now, the contact between man and machine in this closed loop system arises at two places. Where two places? Displaying instruments and controls. You see here, displaying instruments here and the controls. In two places, two places, the contact between man and machine comes into picture. Now, apart from that, environmental factors also will have an influence on the working of the system. The working efficiency of man depends upon several factors, like environmental conditions surrounding the workplace, his own characteristics of man, such as his age, his motivation, his training, whether he has received proper training or not. Depending upon his training, he'll be able to perform, he'll be performing. Depending upon his level of motivation, he'll be performing. Depending upon his age, he'll be performing. Depending upon the prior experience he's having, all these characteristics, okay, on this, the working efficiency of man depends. Information feedback is continuously provided by the machine. It is not necessary that always it should be in the display mode only. Even without displays, you see, even if you are going on a cycle, There are no digital displays or analog displays. Nothing is there. But you will be able to get the feedback after applying the brakes or something, whether it is slowed down or not. You'll be able to sense. Okay, then corrective control measures are provided by man, and that is accepted by the machine. It should accept. Suppose your brakes fail, the machine is not responded. Okay, see, then no, the efficiency of man, working efficiency of man cannot be seen in that case. Okay, so these are the various factors on which the efficiency of the worker depends. Okay, now let us go to anthropometry. Anthropometry, yesterday we have seen that different topics or different disciplines have contributed towards evolving of the subject ergonomics. So one of those topics is anthropometry. Now, what is anthropometry? This is that branch of ergonomics which deals with the shape and size of the body. Now, shape and size of the body means, we are talking about human body. He's a shape and he's a size. This anthropometry. Metry, the word itself, metrics or metry means measurement. Um, Anthropo, I don't know, we have to look up what is the meaning of this, but at least I know this. The metry means for measurement. Okay, so measurement of human body parts, you can say like that. Anthropometry deals with the study of measurement of physical features. What physical features a person has, is he like his body, his linear dimensions, how tall he is, how broad he is, how wide he is, what is his weight, how many kgs he weighs, what is his height, what is his volume, what are range of movements he can do, all these things. So physical features and functions of the human body, that this anthropometry deals with. Okay, anthropometry can also be defined as the scientific study of the measurements and proportions of the human body, which involves systematic measurement of dimensional descriptions of size and shape of human body. See, I will show you one image in which what type of dimensions normally this anthropometry deals with. Okay, almost all the time during day we use one or the other physical facilities like chairs. You see, wherever we go, we look for sitting down, chairs, tables, desks, pens, machines, bicycles, cars, household equipment, etc. You see, can we think of living with those, living without these things? It is very difficult to live. Okay, even in jungle, if we are living also, there also we will look for some kind of a physical facility. Some bed we need, or some shelter we need, or some roof, or something to lean upon. Okay, all these are physical facilities. So during night also, for sleeping we use beds. You see, for if you want to lie down, you want to lie down comfortably. So it is well known that the comfort, welfare, and that is safety and performance of people is influenced by the extent to which these facilities fit people. Fit means they're exactly made for him, and he fit means it is not tight, that is, it is tight in some language, maybe Urdu or something. It is fit means it is tight, it seems. But in English, the meaning fit means it is just the right size. That is what is fit in English means. I don't know if in Hindi also some such meaning is there, but Urdu, it is there, it seems. fit means tight, but here in English fit means just the right size. Okay, now suppose when a physical facility is not designed as per the dimensions of its user, that means it is not fitting that person, then it leads to discomfort of the user. You see, as per your dimensions, see, suppose you are, you have grown up. uh, Suppose you are made to go and sit in your school when you were studying in first standard in those benches. Will you feel comfortable? No, it is not made for you. It is not made to fit you. So therefore there is discomfort. Some more examples are given here. You see, discomfort experienced by a child when driving a big cycle. Say he is a small child, you can say from 6 years 7 years old boy, you make him to ride a big cycle. Can he? You see, he may try, but he won't do it. Cannot do it comfortably. There is a discomfort in that. Or discomfort experienced by an adult when driving a child's bicycle. Child's bicycle, if you take, and can you ride on it? You know, you will be, you will have discomfort. Okay, discomfort experienced by most of the people when boarding a bus with a highly raised platform or narrow gate, like that. See, suppose if you are, some of the buses are not designed properly. This the when you want to enter, the step is very high. You have to lift your leg and place. Even when you are climbing some of the stairs and other things, you can see if the you see the stairs, the steps, normally it should be a comfortable height is 6 inches. So if anything above 6 inches, we feel discomfort, and we'll say, hey, these steps are not made properly. And that too, especially if older people are there, maybe at the age of 50, 60, 70. You see, as you age, along with that, some diseases also come to the body. Okay, after 40 you will definitely need specs, you know and you cannot see, without the specs. And after 50, around 50 or something, there will be pain started in your knees. You'll not be able to walk perfectly, or you'll for sitting, rising, you'll face problem, like that. See, if there is a raised platform in the bus, for boarding, for climbing into the bus, okay, then you will experience discomfort. If the gate is very narrow, you will experience discomfort. And discomfort is experienced by user when wearing tight garments. On this you may have seen, suppose in the 10th standard, what shirts, pants you are having. You see, now after 2 3 years, now if you wear them, how it will be? It will be, it will be very tight. You may not even fit into it. Okay, it will be very tight. With such kind of garments, with such kind of clothes, can you comfortably do the things? No. See, so what we are saying here is, if a physical facility is not designed as per the dimensions of its user, then it leads to discomfort. And here we are saying another statement here. If the physical facility is not designed as per the dimensions of its user, then his safety or welfare also may be in danger. Like suppose, you see, now you are say 5.5 feet tall. See, suppose, when you go to villages and all, there are some of the huts and other things, the doors will be so low. Okay, so they have those, and at that time, you have to bend and go in. You see, by mistake, without seeing, if you are talking to somebody and you just go in, what will happen? Your forehead will bang against the doorpost. See, low height doors, it may cause you some injury. So safety is there, danger is there. So, and width of the berth in trains is smaller. You see, now you're in the house, you are accustomed to sleeping on a bed, 6.5 feet by 3 or 3.5 feet width. Okay, but in the trains, if when you're traveling, what will be the width? Maybe 2 feet or a little uh, lesser than that. You see, if we are traveling for the first time, no, there is a safety consideration. You may fall. Small children may fall from the birds. That's why they don't put on the top birds. Okay, they may fall from there. Okay, the seats provided are not capable of bearing or withstanding the height of the people. Suppose the seats are provided, but they cannot bear your weight. What will happen? Either it will crumble and collapse. Okay, or or some injury or something may take place. So safety also. Say two things. If the machine or equipment or anything that is not made as per the dimensions of the user, he may experience either discomfort or he may face some safety issues. Okay, so today anthropometry plays an important role in industrial design. You see, nowadays anthropometry is considered in every design. Okay, in the initial design stages, they didn't think about it, but as the days passed, and as people started designing, using science, then no, they thought they looked into this also. It is necessary to design as a joint system, man and machine put together. You design, just don't design a machine and leave it, and afterwards you find that there is no right person to operate that machine. Okay, so this anthropometry plays important role in industrial design, in clothing design, in ergonomics and architecture, where statistical data about the distribution of body dimension. You say architecture. What is the you see how tall your door of your house should be. See, architecture means your building now is uh, is uh, is designed by an architect. Okay, so see how big your door should be, how wide it should be. Uh, See, did you ever think how tall door door and how wide the door should be? You see how are we coming to these conclusions? How big it should be? It is according to the ergonomic considerations, or you can say it is according to the anthropometry considerations. Okay, and where statistical data about the distribution of body dimensions in the population are used to optimize products. You see, if you want to use in India, what are the sizes, what is the normal height of the person, what is the normal weight of the person, uh, his forearm, how big it is, his shoulders, how wide they are, his chest, how big it is, his seat and everything. All these dimensions, you will get from taking measurements from the population. Okay, then okay, now let us come to the types of body measurements. See, when you talk about taking body measurements of, body means human body, man's body measurements. When you're talking about this, there can be two types of body measurements. It can be a static measurement, or it can be dynamic or functionally, or when a person is performing something, he is doing a function at that time. That is a dynamic measurement. Static measurement, dynamic measurement. Static means no, he is static, he is not doing anything. Okay, let us see the first one. Static or structural dimension, that is static anatomy data. These are the measurements taken when the body is in static state or in a fixed state or in standard position. That standard positions means what? He's not moving or he's like that. He's not reaching anything. Okay, structural dimensions can be are height, height of a person, arm length, shoulder length, etc. Then structural dimensions might represent a person's reach, how far he can reach with his hands when his or her shoulders and trunk are stationary. See, this is the important thing. When you are saying static measurement, then no, these things are stationary. His shoulders are stationary, his trunk is stationary, he's not twisting his body and reaching something. You see, the whole body should be just like that, only the hands should move, and in what reach it is there. Okay, like that. See, the measurements of different body parts are obtained for various groups of people. Groups of people also, see, if you see uh, you know Punjabis, their dimensions may be different. If you go to northeast, and their sizes may be different. If you go to south India, their body parts may be different. It's a group of people, various groups of people, because body measurements vary as a function of age, as function of sex, and for different from different countries, different states also. In India, such a big country like India, even you see a person from Meghalaya, sometimes those students come to study here, their sizes and our the sizes normally you see about you, they vary. You see, depending upon the age is clearly understood. Small child, small dimensions. Grown up man will have big dimension. Okay, then sex also, that means if he is a male and if she is a female, the measurements differ, and from region to region also differ. So there are differences in anthropometrics of male and female also. Okay, these measurements can be used for specific applications like designing earphones. Now you want to design an earphone, it should fit in your ear. You see, for that, no, first somebody must have measured, see what should be the diameter of that earphone. Okay, then glasses, eyeglasses, for seeing, what should be the your frame, what should be the frame width, and how big or small the glass frame should be, and even the handles that you wear above your handles of the glasses on your ears you wear, how long they should be. And when you're, and also about wrist watches, belts, chains of wrist watches, all such things, these measurements can be used. Not only for that, even for your levers, motorcycle, or a cycle, motorcycle, car, all these when you're applying brakes, even foot pedals and other things, how big should be, how wide it should be, all those things, we have arrived at those things depending upon the measurements of the population. Okay, now we saw about the static dimensions, where all these height, arm length, and other things without the shoulder and the trunk moving or turning about, those are taken. Whereas now if we are talking about dynamic or functional dimensions, these measurements are carried out under the conditions in which the body is engaged in some physical activity. like body is in motion or it is doing some work. These functional dimensions are widely useful for design problems, as in most situations people lack the power to move, but they are moving to operate a machine or to reach across the table for tools or driving the foot pedal of a bicycle. Actually, man is not always, stationary. It is not that when he's reaching to someone, no, his trunk is not leaning forward. See, it should be noted that in performing physical functions, the individual body parts do not operate independently. For instance, the practical limit of arm reach is not just equal to the arm length, but it is somewhat more than the arm length. Why? Because it is affected by motions of other body parts like extended shoulder and trunk. You see, you lean forward. When you lean forward, it is not only the hands, even your trunk, your shoulders, and all those things are stretching forward. So you see, more than the arm's length, you are able to reach. Okay, see, these are the dimensions actually, which are required when we are operating machines and all. We don't want stationary dimensions. We want functional dimensions or dynamic dimensions. In many cases, structural dimensions may be adapted to a specific problem, but dynamic dimensions, they are, better representatives of the reality. Now let us see here. Here a picture is shown. Um, when we are using the available anthropometric data for designing of the physical equipments or machines or facilities, as a designer, you should be careful in selecting the appropriate right data. You see, suppose if you want to, send a um, send some automobile or bike or something to Africa. Suppose you want to send to Africa, export to Africa. You see, so many of Bajaj motorcycles are sent to Kenya. Okay, our autos are available in Nigeria. Our autos are transport. Bajaj autos are exported to Sri Lanka. You see, when we are transporting to, okay, Sri Lanka means, they are also like our size only. But African people, their dimensions are different. They may be taller, and their, you have to design accordingly. You see, generally, a wide range of data may be available, and the designer should use only that data which corresponds to the population. So that means what I am saying is, if you are designing to send to Nigeria, you have to consider that population of Nigeria, their anthropometric measurements, their anthropometric data, and then you should design. Then it will be fitting. If it is like the man machine joint system, otherwise, no, you see, there will be uncomfortably they will be operating. Okay, so those who are actually using the physical facility or the equipment, their that population's anthropometric data we should use. Okay, see, the specific body features measured are shown here. Let us see. Now the stature height. This is stature. Stature height is, you see, from the foot up to the top of the head. This is the stature height. Okay. Then eye height. Eye height means from the ground to your eye line here. Eyes. So this is the eye height. If you say shoulder height, this is your shoulder. So from the shoulder to the ground, this is the shoulder height. Your elbow means, here, where your arm bends, that is elbow. Your elbow height is from there to the ground. Okay, your knuckles height. Knuckles means, these hands, where these fingers join your palm, those knuckles, what height they are from the ground. This is the knuckle height. This is the fifth one. Sixth one is sitting height, erect. When you are erect, when you're sitting erect, that means, from the seat, you're sitting on a chair. So from the seat to the top of the head, this is the sitting height. Okay, this is your, what do they say, torso height. Okay, then sitting eye height. Sitting eye height is from here, from where the eyesight is, to the to the to the seat. Okay, that is the seventh one. The eighth one is elbow rest height. See this elbow. See, suppose if you are sitting on a chair, where should be that elbow, at what height, so that you will feel comfortable? That is the elbow height. That means from the seat to this place. From this is the elbow height. You see these two arrows here. This is the elbow height. Okay, some people know their legs will be longer. Some people's upper body will be longer. It depends. People are made in different ways. Okay. Now, thigh clearance height. Thigh means, this is the thigh. Thigh clearance height means, what are they talking? I didn't understand what it is. Maybe the above the thigh, what clearance is there up to the elbow or something. Is it this gap? But arrow is shown here. I don't understand. Okay, anyway. Now knee height. Knees are here. Knee height is from the ground to the knees. That is the knee height. And then buttock knee length. Buttock knee length means these are buttocks from here to the knee. Okay, this length is buttock knee length. And then popliteal height. I think popliteal means this at the back of the knee. What is here? This is popliteal. So from there to the ground, this is popliteal height. So these are different, dimensions, anthropometric data, or the specific body measurements that we take. Okay. Now, use of structural and functional anthropometric data. Structural and functional anthropometric data is very much essential for designing items for specific groups of people, like adults, that means fully grown up people, for males, for females, for children, etc. Different groups, specific groups of people. The data used should be specific for such groups of people. And you see, for older people, if you are making, you have to make the things in different way. For children, if you are making, you have to make different way. For women, you are making, you have to make it different way. Okay, and also it may vary from country to country. Okay, then stepwise procedure of using anthropometric data is given below. Okay, now let us see the first one. Decide the user population. So user population means, as we were saying, if you want to export your auto rickshaw to Nigeria, okay, your population, who are they? They are the Nigerian people. Okay, user population is the group of people for whom we are designing a physical facility or equipment. Then anthropometric tables provide measurement of different body parts for men and women, which is split into different nationalities and age groups. You see, this data is available. Okay, from that you will be able to collect this data. You see, it is not that all Kenyans or all Nigerians are of the same size or all Indians of the same size. What we say is, the average or the mean dimensions measurements. Therefore, it is necessary to know exactly who is likely to use the equipment and features, physical facilities. Example, we are designing an office chair, and it is necessary to consider adults of working age. Office chair means, you won't be designing for small children. Okay, and even in that, no, you should consider the population, specific group of population. Okay. Now, while designing the doors, the user population would include everyone. See, door means, door into the house you should go. See, small children should be able to go, big people should be able to go, everybody should be able to go. Okay, so you have to consider everything, all the people, and lean person will go, and the stout person, fat person also will go. You see, depending upon that, you have to make your door. Okay, that's why your height, of the doors is around 7 feet in here in our country, and the width is nowadays 4 feet. Whereas if you go to villages and see, they may not be so tall also and so broad also. Okay, then this establishes the dimensional range which needs to be considered. Okay, now second is decide the relevant body measurements. Once the user population is known, the next step is to decide which part of the bodies are relevant in designing the concerned equipment or facility. Now, if you are sitting, your knee height may be important, and your, those here, if you are sitting, not knee height. What is this? Popliteal height may be required. Your seat, this may be required. Buttock to knee length, this may be required, and your torso height may be required. See, because you need to give support thing, and your armrest where it should be. These features may be necessary. For it. For example, in deciding the location of a control valve on a machine, we have to consider the arm length. How how long is the arm? Or depending upon that, the control device on a machine can be designed. Then third one is determine the principle. Determine the appropriate principle which is applicable for the design of concerned equipment or facility. Three principles are used while using the anthropometric data for design of any equipment. These three principles are design for the average, design for the adjustable range, design for the extreme individuals. Design for the average, that's why you see, normally for average people they make footwear and other things, clothes and other shirts, pants. For average people they make. If a person is abnormally having a long feet, okay, for him, no, you may not get the shoe size. You have to give, you have to order and make them. Okay, to the order you have to make those things. Okay, so see now, but for the most of the population, no, design for the average, then that will fit. Okay, design for an adjustable range, a little bit of adjustment also you should allow. Okay, like our revolving chairs, the height of the seat can be brought up or taken down. Okay, then design of for extreme individuals. Extreme individuals means very fat person who cannot sit in one seat, or very fat person who cannot enter into the door, or very tall person, like all those things. Those are extremes. Okay, for them you have to design. Okay, determine the principles. Okay, the fourth one, decide the percentage of user population to be accommodated. For example, either 90% or 95% of user population, for them it should, your whatever equipment you are making, whatever machine you are making, they should be able to operate. It should fit them. Okay, this is 95%, means what? In 100, 95 people can use it, but 5 people cannot use it, like that. This is percentile, means how many people are below you. 95 percentile means what? 95 people are below you. That's how sometimes percentile scoring is there. When you appear for gate and all, they will ask you what is your percentile. Some people will say my is 99 percentile. That means what? Out of every 100 people, 99 people have got lesser marks than you. That is the meaning percentile. Suppose 2 lakh people have 1 lakh people have appeared. That means 99 people are below you, means 1000 people are above you. That is the meaning. Okay, but suppose there are only 500 seats, then what? Then you will not get. Then you need 99.5 percentile. Okay, anyway, this percentile may vary from company to company which are designing and manufacturing the facilities. Okay, you have to decide the percentiles are the percentage of user population. Okay, next is extract the relevant body dimensions. Extract the relevant body dimensions from the anthropometric tables. Like we have, so many measurements data are available. We have seen for machine design also, we were having design data book. For your air conditioning and other things, you have psychometry charts and other things. All such data are available. So here also anthropometric tables are available. So appropriate anthropometric tables for the percentage user population. So you should select as decided in the step 4. Okay, then add allowances if necessary for special cases. For example, if the shoes or thick clothing is to be worn by people while using the equipment or facility, then some allowance you have to give. You see, if a lever you are pressing with the barefoot, or if a lever you are pressing after wearing a leather shoe, depending upon that, no. If your leather shoe you are using, you have to provide allowances, extra allowance, like. Okay. Okay, knowledge about percentiles used in anthropometric data. See what percentile I was talking about. Okay, I think we will stop here today, and tomorrow we will continue with our lecture. Thank you.